Hi, now we're going to look at some practice problems for Chapter 4. I understand that Chapter 4 is a bit tough, especially just the notes. And the theory is a bit tough to understand, but if we do the practice problems, I hope this will help you a little bit. Okay? So let's do the first one. There are 4 red, 3 blue, and 12 green marbles. If you pick one, what do you pick a blue one? Okay. So how many blue? How many blue do we have? We have 3 blue. Out of a total, how many? Let's see, 4 and 3 is 7, plus 12 is 19. So 3 out of 19, if you calculate that, that's roughly 0.158, which is 15.8%. Okay. Suppose there are, oh, this is still highlighted. Suppose there are 5,230 students at FCC and 12 of them are math majors. What chance do you have of picking a student at random and getting a math major? Well, how many math majors do we have? 12. Out of how many total students? 5,230. Okay. And you can leave that as a leave that as a fraction or change it to a percent, and it changes to roughly 0.2%. So 0.0022 is the decimal, and that's 0.2%. So for these probability problems, you want to look at the number of outcomes in that certain category divided by the total number. Okay? 100 people surveyed, 80 like jazz, 60 like reggae, 45 like both. Make the little chart. Alright, so use the information that you know. I know 100 people total and 80 like jazz. So this is liking jazz, J bar is not liking jazz, R is liking reggae, R bar is not liking reggae. Total like jazz is here, 80. 60 like reggae, so that's here. 45 like both, so liking jazz and reggae. And I will post this document on Blackboard so you can print it out and work on it as we are doing this video. Okay? So then you subtract and get the fill in the rest of the cells. So 80 plus what gives me 100, 80 and 20. 60 plus what gives me 100, 60 plus 40. And then 45 and what gives me 60, 45 and 15. 15 and 5 gives me 20. And then 40 minus 5 is 35. And then you can check 45 and 35 give you 80. Okay? Write each of these events in symbols and find the probability. So if I pick somebody at random, what is the probability that that person does not like jazz? So in symbols, that would be not liking jazz. How many people don't like jazz? Total 20. Out of 100 total. 20%. How many people like reggae but not jazz? Alright, who likes reggae? This column right here. But they don't like jazz. So I'm looking for liking reggae but not liking jazz. That's 15. So let's put that in reggae and not jazz. So but means the same thing as and. We said 15 liking reggae but not liking jazz out of 100. Which is 15%. How many people don't like reggae or don't like jazz? So for that, I have to do don't like reggae, or remember this is the symbol for or don't like jazz. So that's, you can use the formula, probability of not liking reggae. So the probability of the first thing plus the probability of the second thing minus the probability of both. Let me do that here. How many people don't like reggae? Let me move this up a little bit. So 40 people don't like reggae. People don't like reggae. How many people don't like jazz? That's this column here, 20. How many don't like both? So don't like reggae and don't like jazz. That's 5. 5 like neither. That's all over 100. So 40 plus 20 gives me 60, minus 5 is 55 over 100. 55%. Okay. You can do that this way, or you can just look at the cells. I'm looking at who doesn't like reggae, who doesn't like jazz. So this column, this row right here, this row right here tells me who doesn't like reggae. This column right here tells me who doesn't like, This row right here tells me who doesn't like jazz. This column right here tells me who doesn't like reggae. So I'm basically looking at these 3 cells, 35, 5, and 15. Okay, 35, 5, and 15 are the cells, or you could do 35 plus 5 plus 15 are the number of people who don't like reggae or jazz. 30, 40, 55. Same answer. How many like neither? They don't like reggae and they don't like jazz. Well, that's just looking at the table. So remember, likes neither means they don't like reggae and they don't like jazz. From the table we can see not reggae, not jazz. That's 5 people. What's the probability of somebody liking jazz given they like reggae? So liking jazz given they like reggae. So for that you have to do probability of both, liking jazz and liking reggae, divided by the probability of the latter one, the probability of liking reggae. How many people like both jazz? So this is from the definition, okay? The formula for conditional probability. How many people like jazz and reggae? That's 45. Out of 100. How many people like reggae? Total 60. The hundreds cancel out, and I get 45 out of 60. Which is 75%. So if you choose somebody who likes reggae, there's a 75% chance that they also like jazz. Are liking jazz and liking reggae independent events? Well, remember, if 2 events are independent, and they prove it using the formulas. So one of the formulas we can use is if 2 events are independent, then the probability of liking jazz given they like reggae is equal to the probability of jazz if independent. Okay? That's from the just your notes. What's the probability of liking jazz given reggae? Well, we calculated that to be 75%. And probability of liking jazz, we calculated it up here, or you can look at it up here. 80 out of 100 like jazz. 75% is not equal to 80%. So therefore, liking jazz and liking reggae are not independent events. Okay? Again, that's from the formulas. Probability of liking jazz given reggae 75%. What's the probability of jazz? From here you can see that's 80%. If they were equal to each other, we would say yes, they're independent. But since they're not equal to each other, they're not independent. So there is some dependency of liking jazz and liking reggae for this example. Maybe because the beat of the music or the instruments or whatever. Okay? Alright. Last problem, let's look at this. You choose 8 M&Ms from a huge bag that is 70% brown. What is the probability of getting all 8 brown? Alright, so first question you got to ask yourself is, when I choose these M&Ms, am I putting them back or not? So, am I choosing with replacement or without replacement? Because that'll change my answer, right? Well, here it really doesn't matter because I'm choosing from a huge bag. I can assume that my population is so large, it doesn't matter whether I put them back or not. So with replacement and without replacement is going to be exactly the same here. Because my bag is so huge, my population is so large, choosing a small sample is not going to affect the population. Okay? So we don't have to worry about with replacement, without replacement. We can assume independence. Okay? Assume that you're not putting them, assume that you're putting them back. It makes no difference. Alright, what's the probability of getting all 8 brown? So what's the chance that the first one is brown? 70%, 0.7. What's the chance that the second one is brown? 70%, 0.7. What's the chance that the third one is brown? 70%. What's the chance that the fourth one is brown? 70%. So it's like 70% for the first one, 70% for the second one, and so on. And since I'm choosing all 8 brown, that's like saying the first brown and the second brown and the third brown and so on. So for that we're going to use the multiplication rule. 0.7 multiplied 8 times is the same thing as 0.7 to the 8th power. When you do this, let me do this on my calculator real quick. I get roughly 5.8%. So there's a 5.8% chance that I'm gonna get all 8 browns, all 8 brown M&Ms. So there's some, how did I know to multiply here and not add? Well, when you see the word and, or you know you want the first brown and the second brown and the third brown, then you're gonna multiply. Use the multiplication rule. When you see the word or, the first brown or the second brown or the third brown, then you're going to use the addition rule. Okay, so that's something you just want to remember. What's the chance of getting no brown? Alright, so if 70% are brown, the rest, 30%, are not brown. Okay? So that's like saying, what's the chance of the first one being not brown? 30%. Second one being not brown, 30%. Third one being not brown, 30%, so on. So it's like multiplying 0.3 8 times. It's to the 8th power. And when we do that, plug this into your calculator. My calculator tells me this. 6.561 e to the negative 5. That means you're going to take the decimal and you're going to move it 5 spaces to the left. So if I go 1, 2, 3, 4, 5, that means I have 4 zeros in front of it. 1, 2, 3, 4. So my decimal was here and I moved it 1, 2, 3, 4, 5. Convert that to a percentage, you move the decimal twice back. That's 0.006561%. That's pretty small. That's pretty close to 0. So if I have a big bag of M&Ms, 70% of those M&Ms are brown, and I close my eyes and pick 8, the chance of getting no browns, so the chance that none of those 8 are going to be brown is pretty low, almost 0. At least one of those has to be brown if 70% of my bag has brown M&Ms. Okay. If I had a bag that didn't have that many brown M&Ms, then it would be possible not to get any brown in a handful. But I got to get some brown. And so that's what this next question asks. What's the chance of getting at least one brown? Remember the probability of at least one? The probability of at least one is 1 minus the probability of none. So the probability of at least one brown is 1 minus the probability of none brown. That's no brown, which we calculated up here. That's 1 minus. So you're going to use the decimal here, 0.00006561, which is 99.99%. So almost 100% chance of getting at least one brown M&M in a huge bag that's 70% brown. This part we haven't exactly learned yet. I want to get exactly 4 brown. Just write binomial here. When we go on to chapter 5 and do the binomial distribution, we'll look at problems like this. Okay? So I hope this helps a little bit. Again, if you have any questions, send me an email. I can make you a little video explaining things. I've done that for students this semester so far. Also, during the vector hours, ask me questions, okay? So I hope that's a little bit clearer for you. Thanks for watching.